Hello, fourth graders. Today, we're going to be learning lesson 7-6, which is all about comparing fractions with unlike denominators. So what I have on the page for you is two number lines that have fourths and eighths. And what I want to do is I want to compare 2/4 and 5/8. Okay? Notice how the denominators of these two fractions are different. So typically, when we have different denominators, we would feel that we can't compare them. So what I have for us is two number lines to help us with this comparison. And then in this lesson, I'll also teach you how we don't need number lines. I have different methods, okay? So to compare 2/4 and 5/8, I can see that 2/4 is right here, where I put the star. 5/8 is here, where I put the star. Obviously, the one further right on a number line or closer to 1 is a greater fraction. So I would say that 5/8 is greater than 2/4. Or I could even word it like this. 2/4 is less than 5/8. I will show you a few more examples of this, but I am also going to show you how we don't actually need number lines to see this. All right, guys, so like I said, I'm going to show you a few different ways to compare fractions that have unlike denominators and numerators without using number lines, okay? So this one right here that I have 3/5 and 5/10. What I'm going to do first is check to see if one of my denominators has a factor of the other. And let me explain. So what I see is that 5 is a factor of 10 or is a multiple of 10 because 5 goes into 10. So I can make a common denominator by finding equivalent fractions. So what I mean by that is I have 3/5, but I want it to have a 10th in the bottom because I want to be able to compare both fractions with the same denominator. Makes it quite easy for us to compare. So how do I change 3/5 to how many tenths? Well, what I had to do to the fifths is multiply by 2. Well, whatever I do on the bottom, I must do on the top. So 3 times 2 is 6. So what I'm saying is 3/5 is equal to 6/10. Well, now that I have 6/10, I can compare it to 5/10 quite easily because the denominator is the same. Well, when I'm looking at 6/10 and 5/10, I know that 6/10 is more than 5/10 because the numerator is larger. Let me do another one of those for you. So again, we are just looking for common multiples of the denominator. So if I had, let's say, 3/4 and 7/8, and I want to know which one is bigger. Well, right away, I'm looking at my denominators. They are not the same. My numerators are not the same. So I need to figure out another way of comparing these fractions. Just like before, I'm going to notice that the 4, this 4, can go into this 8, meaning there's a common multiple. So I want to find the equivalent fraction to 3/4 with an 8 on the bottom, so I could compare easily. Okay, so what did I do to 4 to get to 8? I multiplied by 2. Whatever I do on the bottom, I must do on the top. So 3 times 2 is 6. Now I can compare 6/8 to 7/8. Obviously, with the same denominator, all I do is compare numerators, and 7 is more than 6. So 6/8 is less than 7/8. So that is one way that you could use to find or compare fractions with different denominators. The next one I'm going to show you is not as easy because there might not be a multiple for it. So let me show you that one. All right, guys, so I'm going to show you another method, but this one's for when you do not have the denominators as common multiples, or where one denominator will not go into the other. And I'll give you an example of that. So if I have 5/8 and let's do 4/5, and I want to compare these two fractions, see which one's bigger. I know that 8 does not go into 5, 5 doesn't go into 8. So what I would suggest is just multiplying the denominators to get your new denominator. Let me show you what I mean. So 8 times 5 is 40. So 40 is going to be my new denominator, okay, on both fractions. But what did I have to do to this 8 to get to 40? I had to multiply it by 5. Well, whatever I do on the bottom, I must do on the top. So I have to multiply the top by 5 as well. So 5 times 5 is 25. So 5/8 is equivalent to 25/40ths. Okay, let me show you the other one. How did I get from 5 to 40? Well, 5 times 8 we did to get to 40. Whatever we do on the bottom, we must do at the top. So 4 times 8 is 32. So what I have is I have 25/40ths and 32/40ths. Now my denominators are the same. All I have to do is compare numerators. And obviously we know that 32/40ths is bigger than 25/40ths. I'll give another example of that. So if I have 3/5 and 8/9, and I wanted to compare these two. And I noticed that 5 does not go into 9, 9 doesn't go into 5. So the easy thing that we could do is just find the common denominator. So I could do 5 times 9, which is 45. So my denominator for both fractions will be 45. Well, to get from 5 to 45, I had to multiply by 9. Whatever I do on the bottom, I do on the top. So 3 times 9 is 27. So 3/5 is equivalent to 27/45. Next one. What did I do to 9 to get to 45? I had to multiply by 5. Whatever I do on the bottom, I must do on the top. 8 times 5 is 40. Now I can compare fractions because I have 27/45, 40/45. Denominators are the same, so just compare numerators. 27/45 is less than 40/45. I know this video has got a lot of different strategies, but I got one more to show you. So let me go on to that. All right, so I have two more fractions right here where it's 5/8 and 7/12. The strategy that I showed you just a moment ago would be to multiply 8 times 12, which is 96, which most definitely will work. But what I could also think about is a common multiple of 8 and 12. This will give me a simplified answer compared to a bigger number, which 8 times 12 would be 96. It just doesn't make a whole lot of sense. Even though we can, what I could do is find a smaller number that both of these numbers go into. So let me explain. So if I list out every multiple of 8, I would go 8, 16, 24, 32, and 40. I think that would be enough. If I list out the multiples of my 12 over here, what I'm trying to do is find a common one, the first time that they match. So I have 12, 24, 36, 48. These are the multiples of 12. Again, what I'm looking for is where they have a match. And I found one pretty quickly, and I have it as 24. Both of these have a multiple of 24. So again, this is just going to make my fraction a little bit smaller, because now my new denominator is going to be 24 for each of these fractions. So now I'm going to do the same steps I did in the previous strategy, just with 24. So how did I get from 8 to 24? Well, I had to multiply by 3. Whatever I do on the bottom, I must do on the top. 5 times 3 is 15. Okay, next one. How did I get from 12 to 24? 12 times 3. Oh my gosh. Sorry, guys. 12 times 3. 12 times 2 is 24. Whatever I do on the bottom, I do on the top. So 7 times 2 is 14. So I have 15 24s, 14 24s. So my denominators are the same. It means I could compare my numerators. And I know that 15 24s is bigger. I'll show you another example here. Okay, so if I have 5 6, and we will do 3/4. I know that 4 can't go into 6, 6 can't go into 4. I could just multiply the two denominators to get to 24, but what I'm going to do is list out the multiples to see if I can find a smaller denominator than 24 that is common. So listing out the multiples of 6 would be 6, 12, 18, 24. Listing out the multiples of 4 would be 4, 8, 12, 16. I found a match right there at 12. So let me go ahead and get that highlighted. So I have a match at 12, which means my new denominator is going to be 12. So how did I get from 6 to 12? I multiplied 6 times 2. Whatever I do on the bottom, I must do on the top. 5 times 2 is 10. So 10 twelfths is equal to 5 6. Then I have whatever I did to get to 4 to 12, which is multiplied by 3. Whatever I do on the bottom, I do on the top. 3 times 3 is 9. Denominators are the same, so I just compare my numerators. 10 twelfths is greater than 9 twelfths. All right, guys, so this is going to conclude our video for today. If you have any questions, please be sure to ask them when we return to class. Have a good night.